Congratulations! You've just created and run your first iOS app in the simulator. That's an exciting milestone, and today we're going to dive deeper into making the most out of this experience while exploring some handy features, enhancements, and techniques to further your journey as an iOS developer. So far, we've learned about the importance of the Developer Ops Certificate and the steps required to set it up for running an iOS app on a physical device. We explored how to create a development certificate, configure Xcode with provisioning profiles, and verify the ops trustworthiness on a device. Additionally, we discussed debugging techniques and best practices for testing, ensuring a smooth user experience. Through these processes, we've laid the groundwork for successful iOS app deployment and development. Now, we'll cover running your app, troubleshooting common issues, and implementing improvements to enhance functionality. So, let's get started. First things first, when you're running your app, always make sure to look out for unexpected behaviors. It's pretty common to hit snags, like those pesky warnings during development. Just remember, they're there to help you catch potential issues. Now, in terms of troubleshooting, if something doesn't work as expected, don't panic. Start by checking your console logs. They can give you hints on what's going on. Now, let's talk about enhancements. Consider implementing user feedback mechanisms to improve your app over time. Engaging with your users directly can reveal invaluable insights. All right, so as we journey forward, keep experimenting. Try out different features, and don't hesitate to reach for the documentation whenever you need clarity. Remember, even seasoned developers rely on guides. With each step, you're going to build your knowledge and skills as an iOS developer. So embrace the learning process, and let's keep moving forward.
Let's kick things off by exploring how you can run your app in different scenarios. You've probably been working with the simulator, which is a fantastic way to test your app without needing a physical device. But let's not forget, testing on a real device is crucial. When you run your app on an actual device, you truly get to feel how it interacts with the hardware, how it manages battery life, and of course, its performance under real-world conditions. So to run your app on a real device, it's pretty straightforward. First, just make sure your device is connected to your Mac and it's trusted. Next, open your Xcode project. And now here's the fun part. Select your device from the device list in the Xcode toolbar, and then just click that play button. This will compile your app and deploy it directly to your device. Easy peasy, right?
The accompanying figure, titled Key Concepts in iOS App Development, presents a ranked distribution of focus areas by importance, which is expressed as percentages. Now, the tallest bar corresponds to running the app on device at 35%, indicating that testing on physical hardware is, well, the single most emphasized activity. The second largest bar is running the app on simulator at 25%, showing that simulator-based testing remains a significant but secondary focus. Then we have debugging techniques, sitting at 15%. This highlights that active debugging receives notable attention, though still less than direct testing. Logging user actions registers at 10%, suggesting that instrumentation and runtime logging are indeed important practical tools for understanding user behavior. Lastly, user feedback integration, error handling, and continuous learning, each at 5%, form a lower tier that still represents essential, ongoing commitments. From these values, we can conclude that practical execution and observation, like device and simulator testing, take priority. Meanwhile, the diagnostic practices, which include debugging and logging, serve as substantial supports. The smaller allocations for feedback, error handling, and learning underscore that these responsibilities are continuous and should not be neglected, even though they receive fewer immediate resources.
Now, there's nothing quite like the anticipation and, let's be real, the tension of launching your app for the very first time on a real device. You might feel super confident, thinking you've covered all your bases, but things can sometimes go a little sideways. One common issue you might run into is, you guessed it, code signing errors. These usually pop up when Xcode is a bit lost and can't find the right provisioning profile for your app. To tackle this, go ahead and navigate to the Signing and Capabilities tab within your project settings. Once you're there, just make sure you've selected the correct team and that you've got the right provisioning profiles in place for both debug and release builds. That should set you straight.
Now, let's see how we can implement a function to process user input effectively. In this example, we define a function named processInput that takes a single parameter, input, which is a string. The main purpose of this function is to handle. Now, let's see how we can implement a function to process user input effectively. In this example, we define a function named processInput that takes a single parameter, input, which is a string. The main purpose of this function is to handle the input provided by the user, ensuring it's free from unnecessary whitespace or new line characters. First, we utilize the trimming characters method to remove these extraneous characters, creating a new variable called processed. This is critical since user input can often contain unwanted spaces that could lead to errors or misinterpretations in our application, definitely something we want to avoid. Next, we employ a conditional statement to check if the processed variable is empty after trimming. If it is, the function returns a user-friendly message indicating that no input was provided. Conversely, if there is valid input, the function constructs a string that includes the processed input, which can be really useful for informing the user of the data they have entered. This approach not only enhances user experience by providing clear feedback, but also demonstrates good practices in handling and validating user input within our application. Now, let's take a look at how we can implement logging to track the app's behavior more effectively. In the given code, we override the viewDidLoad method, which is a fundamental part of the view controller lifecycle in iOS. This method is called after the view controller has loaded its view hierarchy into memory. By invoking super.viewDidLoad, we ensure that any necessary setup to find in the superclass is executed first. Following that, we introduce a simple yet powerful logging mechanism using the print function. Within this method, we include a line that prints a message to the Xcode console stating "view has loaded." This log serves as a confirmation that the view has successfully appeared, offering immediate feedback during development. Utilizing print statements like this is extremely useful in the early stages, as it helps you track the flow of your app and understand what methods are being called and in what order. Now, as you progress, remember that while print is excellent for development, transitioning to more robust logging frameworks will be beneficial for production. They offer enhanced management of log data and functionalities, which can really streamline your debugging process. So keep that in mind as you refine your application further. Next, we're going to write a function to validate user input, ensuring it meets certain criteria before moving forward with any processing. The function is called isValidUserInput, and it takes one parameter, input, which is a string containing what the user has entered. First thing we do inside the function is trim away any unnecessary whitespace or new line characters from the input using the trimming characters in method. This step is super important because it helps prevent users from, accidentally entering just spaces, which we definitely don't want as valid input. So after we trim it, the function checks if the resulting string is empty. If there's some content, it returns true, and if it's empty after trimming, it returns false. Now, by wrapping this validation logic in its own function, we can reuse it throughout our application. Instead of writing this validation code over and over in different spots, you can just call this function wherever user input needs to be checked. This not only cleans up your code and makes it more maintainable, but it also reduces the chance of bugs. Since any adjustments to the validation logic only need to be made in one place, it keeps everything neat and less prone to errors. Which is exactly what we want.
Now, let's see how we can implement error handling in our app using Swift's do-catch blocks. In this example, we define a function called fetchData, which is responsible for retrieving data from a database. Inside this function, we start with a do block, right? Here, we attempt to call another function, fetchDataFromDatabase, which could throw an error if something goes wrong during that data retrieval. By using the try keyword, we send a clear signal that we're aware this operation might fail, and we're prepared to handle any potential errors that could arise. Now, if the data is fetched successfully, we're going to print a confirmation message along with the retrieved data. However, if an error occurs, the execution will seamlessly jump to the catch block where we can manage the error in a graceful manner. Here, we'll print an error message to the console that contains the localized description of the issue.
This approach prevents the app from crashing and allows us to inform the user or even log the error for further investigation. Proper error handling not only enhances user experience by managing failures seamlessly, but also aids significantly in debugging and maintaining robust applications.
Now let's implement a button that will remain centered in the user interface, making for a polished experience across devices. We start by creating a UI button of type system, which allows for consistent appearance and behavior with other native iOS components. After setting the title of our button to Press Me, it's essential to disable the automatic constraints provided by the system by setting Translates Auto-resizing Mask into Constraints to False. This step is crucial as it indicates that we'll be using auto-layout constraints to manage the button's position manually. Next, we add the button as a subview to the main view, ensuring that it will be part of the view hierarchy and displayed on the screen. Now, let's see how we can set up the constraints to ensure that the button remains at the center of the view. By activating the constraints, we pin the button's horizontal center, the center X anchor, to the view's horizontal center and the vertical center, the center Y anchor, to the view's vertical center. This programmatic way of setting constraints guarantees that regardless of the device size or orientation, our button will always appear perfectly centered, contributing to a user-friendly interface.
As we wrap up, let's take a moment to appreciate the importance of continuous learning and staying updated with the latest iOS advancements. Apple frequently rolls out updates to its frameworks, introducing exciting new features and enhances performance. Keeping pace with these updates will not only boost your app's functionality, but also establish you as a well-informed developer in the community. Now, a fantastic place to stay in the loop is through Apple's developer documentation and forums. Here, you can dive into discussions and discover fresh techniques shared by other developers. Engaging with the community on platforms like Stack Overflow or through iOS developer Slack channels can offer you invaluable insights and tips. So today, we covered quite a bit. We talked about how to run your app, both in the simulator and on real devices, troubleshooting common issues, the critical role of debugging, how to log user actions effectively, perform refactoring, manage errors efficiently, and elevate user interfaces. Now take this knowledge and go out there to enhance your skills, because honestly, there's a whole world filled with possibilities waiting for you in iOS app development. Happy coding!